let me know, or you can put in the chat also, how many of you do not know array or have heard the word first time, or you may have heard but you don't know what actually an array is. So is there anyone who don't know what array is, or maybe do not have a proper understanding of array? Then I'll start from there. If all of you know what array is, then I don't need to explain it. So please let me know in the chat box if there is someone who doesn't know array. I'll wait for 13 seconds. All right. So I assume all of you know what array is. Basically, array is a collection of similar type of objects. So NumPy is basically an array. So it's a module created in Python to make your work easier. So there are many functions in NumPy which you do not have to do. So let's say you want to calculate, you want to plot a sine curve, or you want to let's say define addition of two matrices. So in normal programming languages, we start from scratch. So we start like from a for loop and a while loop, and then we create everything from scratch for all the codes. NumPy, so the advantage of Python is that there are several packages available: NumPy, Pandas, Matplotlib. You just need to call the package and then work on it. So NumPy is a package which is mostly an array-based package. And in this class, I'll be showing you how NumPy exactly works, what all things you can do with NumPy, and some of the basic tasks that you should be looking while using NumPy. So let's start the first thing. So whenever you are using a NumPy array, or whenever you are planning to use NumPy, the first step you should do is import NumPy. So once I have imported NumPy, so this means I can use the NumPy package anywhere, but I don't want to write NumPy everywhere. So I just want to write import NumPy as NP. It's your choice. You can write import NumPy as NPL. It doesn't matter, right? But whatever you are using here should be consistent always. So I suggest you all to use NumPy as NP. So because that's a standard notation, but it's not a compulsion for the code. So now let's look into some of this basics of this array, how to use it. So let's start with an example. So let me create the first array. So A is equals to np.array, and then how you define the array is something inside the list. So 2, 3, 4, 5. So if I run it, and now if I print it A, it will show me array 2, 3, 4, 5. So this is how you have to define an array in NumPy. So now it's A is an array or a NumPy array. So now let's say you want to check the data type of this array. So you can just check. If you remember, I told you how to check a data type of anything. So it's an integer. So now let's define something different. So 5.9, 4.7. Now, if you see this, you can see this is a float. So whenever you are defining your numbers inside the list and then calling it, the data type is automatically decided by the compiler itself. You do not need to predefine it beforehand. So this is 1D array. So how do you define 2D array? So for 2D array, you just need to do it np.array and within brackets. So in this case, you have to use 3 brackets. So just write down this, let's say 1.4, 2, 9. This is one set I have. And then again, another set I have is 4, 8, 9. That's it. And now if I run it, so now if you see, this is a 2D array. So 1D means it's one-dimensional array. 2D means it's a two-dimensional array. So there are 2 sets of values. Similarly, you can define 3-dimensional, 4-dimensional. It's up to you. 9, 8. And then if you run it, you will get a 3-dimensional array. So in this way, you can create n-dimensional array as much as you want, right? That's one of the thing. So now let's move. How do you define the data type? If you, let's say you want a particular array to be of a particular data type, then you can define it here only. So let's, for an example, I want to create a complex array. So data type I can define here, complex. So if I run it, I should get a complex array. So you can see one point, since this is a since this is a uh, um, complex, since this is an integer values or floating points value, so there I do not have any component of complex numbers. So this is showing 1.4 plus 0.1j. So this is how you can define your arrays in NumPy. 1D, 2D, complex, integer, float, whatever type of array you want, you can define it. So now there are some functions, special functions in NumPy, which I will be showing you. So first is zeros. So first function is zeros. So first function is zero. So np dot zeros. So if you want to create an array with particular row and particular column and all the elements as zeros, then you just need to use this function np.0. Let's say I want to create here with 3 rows and 4 columns. So here you can see I'm getting an array with 3 rows and 4 columns, and you can see here all my elements are 0. So this is how you can create any dimension. So if I put 5 by 4, I should get 5 by 4. So you can create entire 0 arrays using in NumPy using this function np.zeros. So now similarly we have another function np.ones. So how do you do that? So let's say I'll do the same thing, 5 comma 4. So if I do that, I should get all the 1 1 1 1 1. So let's say you want to have all the values as 1 in your array. You can do it. There are, so these are two major functions. So one is np.zeros and one np.ones. So then there are other functions also. So if you remember in our previous class or one of our previous class, we defined a function called range function, right? So you have, if I give a number 10 to 20 and in interval of 1, so it will start from 10. I guess all of you should remember if you have at least revised once. So it starts from 10 and it will end at 19 in steps of 1. In steps of 1. So this was the picture, like in previous class. If you just go through it, if you have forgotten it. So this function we defined, same thing, same type of thing, you can do it in NumPy. So this function is np.arange. So np.arange, let's say I will do 10 comma 30 comma 5. So I want numbers starting from 10 in steps of 5 till 30, but 30 will not be included. So if I do it, let's see what I get. So I get 10, 15, 20, 25. That's what the arrange function is. It's similar to range functions that we have done in our previous classes. So if you are using NumPy, you can also do this. So similarly, this np, I'll just show one more example, arrange function. So let's say 0 to 5 in interval of 0.3. So if I do this, you can see that it will create in terms of interval of 0.3, and that's how this things works. So remember, it accepts float arguments also. It's not only that it works for integers, it works for floating point numbers also, right? So that's how it works. So now let's look into some other functions. So okay, so now if you have to define pi in any other languages, I don't know how you define in other language. I think in Fortran you have something directly you can call pi in Fortran 90. I don't know, I forgot about 77. For other cases, you define pi as a constant 3.14 or 22 by 7 in the beginning of your program as final float, and then you use it. Whereas for in Python, you do not need at all that case. So if you want pi in any function, let's say, so you just do this from NumPy import pi, right? So if you do it, so this this pi is now your that pi. So you just check what is the value of pi, 3.14 something something, whatever it is. So this is how you can call the pi function anytime from numpy. You do not need to define it with your hand, right? So this is one more advantage. It's not an advantage, but this function is available in numpy. Now we will talk about another function called line space. So as you know, this means that of course there is a spacing between something. So I'll show you how these functions work. um, so line space, how does it work is that, let's say if you have any doubts at any point, you can ask me. I will stop and explain you. So just speak up if you have any confusion at any point of the time. So yeah. So now how does this line space works basically? So you have um, let's say you have a range of numbers starting from 2 to 9, let's say, or say, let's say you have numbers from 0, from a starting point to ending point, and that you divide into equal parts. How many? That you can define. So that is what this line space function actually does here. So I'll show one more example of line space function. So np dot line, then space or linspace, and let's say I want to define from 0 to 2, and I want to make 9 slices of whatever is the numbers. So you can see I have 0, I have 0.25, I have 0.5, I have 0.75, 1, 1.25, 1.5, 1.75, and 2. Let's say I want to make it into 10 slices, for example. Then I will get 10 numbers accordingly. If I want to create 11 slices of this, I will get 11 slices. So this function helps you to create equal number of slices between 2 points. So that is how this line space functions basically work. So let me show you an interesting example where you will be seeing the use of line space function as well as matplotlib as well as some other function. So again here okay, let me show you one more example. So let's say x is equals to np dot line space 0 to pi 100. Okay, so between 0 and 2 pi, I want to create 100 points, let's say, and now I have created 100 points between 0 and 2 pi. So if you see here, I have 100 points between 0 and 2 pi. Now same thing, I want to calculate what is the value of sine at each point. Let's example any example we can say, or cos. So let's say in Python, whenever we want to import sine function or cos function, we just do this np dot sine within bracket x, or let's say I'll write it as y is equals to np dot sine x. Or if you want to find out the cos of something, np dot cos of x, right? Or if you want to find out tan x, then np dot tan of x. So but why should you trust me? I guess whether it is performing or not. So you can just do this, import matplotlib dot pyplot as plt, then plt dot plot within bracket y. So if you do this, you should get a sine curve. You can see here I have got a sine curve here, right? So now let's plot z, plt dot plot. If I put z, then I should get a cos curve, right? Now let's say I want to see how is the tan curve, plt dot plot, and then P was the function, I guess. And then you can get the tan curve. So this is how this Python, so these are some of the features of Python. It's not very hectic. You can plot sine curve, cos curve, and whatever, tan curve, any trigonometric functions, or use them in your work very easily. It's not very difficult. So just play, you have to just give more time to it to understand this thing. That's what I can say. So now this was some of the basics that I wanted to show you. Now I want to show some more detailed function. So we discussed about range function, I suppose. Yes, we discussed about range function. So now let's talk about reshape function. I think reshape function. So now this function is also very interesting. So what this function does is it reshapes your array. So let's say I'll give one example, np dot a np dot a range, right? So range, and then you put the number, whatever it is I want. So if I print a, so I will get an array 0 1 2 3 4 5 6. I'm just showing you an example. So, okay, I got two questions. You people can go and ask me directly if you want in the chat box. Don't want to ask? Okay, I'll answer. Why it is showing 64? It can be 32. Yes, you can have integer in 32 bits. I guess you were asking here or something like that. Okay, so mostly integer is 64 bits, floating is also 64 bits, but I think it depends on the system architecture, how you define it. It depends on your machine, whether it's a 32-bit or a 62-bit integer or float. Second question, high, if we take 0 to 2 pi and divide it by 50 or 30, then what will be the sin x curve? You try it out. It will be a sin x curve only. If you have more number of points, it looks good, but it does not mean that you cannot do it. So, okay, for your sake, I will just show it since you have asked the question. So let's say I'll take only 30 points. I'll still get a sine curve. It's not like I'll not get a sine curve or whatever. So you can see I'm still getting a sine curve, but if you see the curves here, it's not as smooth as it is expected. If you decrease the number of points, let's say you have 10 points only, so then you have less points and then you do not get the smoothness of the curve, right? So more number of points helps you to get a smooth curve. Less number of points, you will get a curve like this. But at the end of the day, it's a sine curve only. So I think that answers your question. Yeah, that's it. So now we'll move to the next section of this part, so that I was discussing. So a range, basically we discussed before also that a range function actually gives us list of numbers that we want. So let's say np.arange 12, if I put, so it will give me 0 to 12, but this is a one-dimensional array. I want to reshape it into two-dimensional or three-dimensional or whatever it is. So how do I do that? So the simplest way to do is a equals to np dot a range, and then you put it 12 or whatever it is, it doesn't matter. Reshape four comma 3, and then you reshape it. So you can see that 0 1 2 3 4 5 6 7 8 9 10 11. So the same array I have reshaped it into 4 comma 3. Similarly, if I want to reshape it in some other way, I can do that, right? So this reshape function basically reshapes your array. So the way you want your array, you can get it by using this reshape function. That's what it is. So now let's look into another example of this reshape. This is a very important function. So it need not be a range always. There can be, you can have a one-dimensional any form of array, and sometimes you need to reshape it. So remember, this reshape function is very important. I will show you one more example. So if I do this and then reshape, I want to create a 3-dimensional array, not a 2-dimensional. So 2 comma 3 comma 4. If I want to reshape it, right? Now if I print a, so you can just always type a, or whenever you are not doing it from mat.lib, you can just type print a or a both will give you same output, so it doesn't matter. Yeah, the comma is missing. So you can see here that whenever you print, okay, the array is also not written here because you are printing the array only. So you can see here that this is a 3-dimensional array, 0 1 2 3 4 5 6 7 8 9. So the way I want to reshape it, I have reshaped it. So I need 2 segments here, I need 3 columns, sorry, 3 rows and 4 columns. So that is how I wanted my array to be, and I have defined my array in that fashion. So these things are allowed. It's okay. So you can do all this stuff in Numpy, and so this is very important function. So now let me come to some other things that you may face in Numpy. One of the such thing is np.arange. So if you put it in numbers like 10,000 or something like that. Now let's say if I put it, so you will see here dot 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 or something like that. So whenever you're seeing dot, it means that numbers are missing. You will not be able to see them. So if you want to see them, you have to just print it and then save it somewhere. Okay, so I'll come to the save options. Don't worry, I will show you how the save things work. Okay. So, okay, now only I will show you. So whenever you want to save something in a text file, the command is np.save txt, within bracket, write the name of the file. Let's say python.dat or whatever is the command, and then write what you want to save. Let's say I want to save the value of a. So if I click here, okay, it's expected 2D array. Okay, 2D arrays you cannot save it. So this should save. Okay, so now I have saved this, and now if I open it here, it should be somewhere here. So how did I save it? Python.dat, right? So if you just check here, it should be in the python.dat. A B C D F G H I J L. Okay, so python.dat file is created here, and you can see this has saved all my values. You can define the other functions that are required. How do you want to save it and all those things? I will come in details, but I just wanted to show that you can save anything in Python in this way, right? So that's what the thing is. So now we are done with the basics of NumPy. What all you can do with NumPy, what all features NumPy have. So now let's look into some of the basic operations of NumPy, right? NumPy is not a very small thing, so it will take around 2 to 3 classes to finish everything. But in the meantime, after the session ends, I know since all of you are here in today's session, you people are interested, that's why you are here. So please revise what I am teaching, and I'll send you a material. Just go through it once and keep doing it on your own. The more you practice, the more you learn it, right? So that's important. Good. So now let's look what happened here. No, I didn't want this. Anyways, so markdown. Yeah, so now let's look into some of the basic operations, not basics. Sorry for that. Okay, basic operations. So we'll be doing some basic operations in NumPy here today. So let's see what all we can do. So let's define 2 arrays, right? So what happened? Okay, a is equals to np.array, and then you write it 2 4 5 6, and then you take another array b is equals to np.array, and then you define it as like 3 4 6 4, whatever. So now I have 2 arrays here, and I'll do some basic operations. So first operation is, let's say I want to subtract a minus b. So you just do c is equals to a minus b, right? So if I do this, and then if I print c, then I will get this array -1 0 2 2, right? So this is how this numpy works basically. So you do not need to go to individual element and subtract them. You can just do it in one line. That's it. Now let's say you want to make some changes. You want to find out what's the a square of a number or something of a particular array. So what you do is that a star 2. Okay, and now it will get square of every number, right? So let's say a cube you want to find out of, you want to do the cube of every numbers, then you just need to do it a cube 3. So now let me show you an example. So you want to save this array in Z. So now if you do it, now you print Z, then you should get the cube root. But if you print A, then your original array is the same array. So remember, always save your values into some other array, right? And then you can use this. So now let's look into another function. So okay, you can even put an array into another function. So let's take I want to find sign of all the values in A. So this I already shown, but still I'll show you. So if I do np.sign A, it will take all the elements, individual elements, and then find out the sign of each of them, right? Or did it do that? Yes, that's it. So this is how it works. So now again, there are Boolean functions also. You can use it. So if a greater than 3, then it will show you whether it is true or false. So you can see here, let's look into the A array. So 2 is 2 greater than 3, it's false. 4 is greater than 3, false, true. 5 is greater than 3, true. 6 is greater than 3, true. So the similar thing you can do with any numbers. So it will tell you false, true, right? So these operations also you can do it with array. You do not need to go to the individual arrays. You can just simply do it. So that is what this extra advantage you have in Python. So now let's look into some other functions maybe. So some of you may be from physics and maths background, I assume, right? So you all know what a dot product and a cross product is. So for Python also you have the same dot product as well as cross product operations. So it's like, okay, I'll show one example maybe that will be good. So let's take a 2 by 2 matrix. A is equals to np dot array, and then okay, I need a 2 by 2 array, so this should be here. Okay, comma 1, and then after that okay, that should be fine. All right, this is fine. Okay, same, I need a B array. So B array I need. So 2 comma 0, and let's say 3 comma 4, and so if I multiply A into B, if I do it, then I get a normal multiplication, right? Element wise product, I'll get it. Okay, now if I write A thread B, this is called known as matrix product. So I'm not sure if you know what is element wise product and what is matrix product. So go once, check what it is. If you have any doubt, I will explain it in the next class, or just drop me an email. So just check once, try it on yourself. You will be able to figure out, I guess. Element wise product. Okay, so this is A at the rate B, and now if you want to find out a dot product, so you can do it. This A dot B, then it's a dot product of this. So just try it out. Just look, even if you don't know what is a dot product, what is a cross product, what is a matrix multiplication, just go once, check it out. If you have any issues, you let me know on this, right? Now, you can even use the other operators that I have shown you in the previous classes. If you remember, if you don't remember, it's great, but still, just a second, I'll take one of them for a sample for the next discussion class. Okay, so even if you don't know some of these functions, that's absolutely fine. We'll have a revision again. So let's say we have B here, this, and if you remember, I showed you A equals to A into 3 can be written as A star is equals to 3. So I showed you people that you can do this in Python. Not only in Python, in many languages you can do this, but I don't know if you people remember or not. Anyways, so I will be doing the same thing. B star is equals to 3. So if I do this, now if I print B, so you can see all the elements of my B are multiplied with 4. Sorry, with 3, right? So these operations also you can do it. So let's say B, okay, I need A also for that. Just a second, I'll just pull this A from here. Okay, so now let's say if you want to do this, B plus is equals to A, right? So now if you do, and now print B, so you can see 11, 16, 14 and 18, right? So how I'm getting these values, let me explain you. So B plus equals to A, it implies that this is B is equals to B plus A. Now, what is my value of B? Remember, this B is now updated. The first element of B is 9. Second element of B is 12. So let's take element by element. 9 is the first element of B and first element of A is 2. So 9 plus 2 is 11. Similarly, you see second element of A is 12. Second element of, sorry, B is 12. Second element of A is 4. So 12 plus 4 is 16. So third element is 9. 9 plus 5, if you add, you get 14. And similarly for the last element, 12 plus 6, you get 18. That's how this function works. So all the operators, so you can see we have discussed assignment operator, arithmetic operator, and different kinds of operator. I think I had a complete session on operators for in the starting classes, I think class 3 or 4. So just go through the session if you don't remember. All the operators that we can use in Python can also be used in Numpy arrays. So most of them, just try back if there is any mistake or if something that you do not get it right. So that's it. So now let's say so this is what this basic operations that I wanted to show you. So now we can do something more. So but we have only 2 minutes 25 seconds for this meeting, so I request all of you to leave this meeting and I'll start another meeting just with the same link. Just join in, right, all of you. So yeah, that's it. I'm just ending this here and you join the meeting with the same link. Okay.